In a circle with center O, what is the measure of angle A? Now, to find here, I need to find the measure of angle A. Where's the angle A? It is here. Where's the sides of angle A? It is this one and this side here. Since these are the sides, so this will be now the intercepted arc. To find the measure of the angle A, we say that it is half the measure of the arc. Now, where's the intercepted arc? Let's name this. This is B, C, and D, and D. Where's the intercepted arc?
BCD.
It is BCD. Bravo. So this is an angle A, and this is an arc BCD. That is an intercepted arc, or that's an opposite arc to the inscribed angle A. Now, before I continue, is it clear now from where we bring the arc?
Yeah.
Okay.
Yes.
Then, what is the measure now of the arc BCD?
180.
How did you know, Haneen?
Because it should be 180 because of the angle O.
Because it is semicircle. Is it right? Here, is it semicircle? BCD is a semicircle. So its measure is 180. Half of it is the measure of angle A, which is 90 degrees. Think about it 1 minute. So here, the angle A, its arc is BCD. The measure of BCD, since it's a semicircle, how did I know it's a semicircle? A semicircle, it's a circle or shaded circle from up to the, this is a semicircle. Here, let's write it like this. This is a semicircle. Here we have a diameter. Diameter cut the circle into 2 equal halves. So this one we call it semicircle. The measure of the arc here is 180. Since the measure of the semicircle is 180, so the measure of this inscribed angle will be 90, which is half of 180. Is it clear?
Yes, teacher.
Yes, teacher. Yes.
Now, let's solve this one here. Here, I'm going to ask you to find the measure of angle A, B, C, and D. Now, look at angle A. Where is angle A? This is here. Or inaccurate. This is angle A. Now, angle A, the size of it is this one and this one. So where it's inscribed, where is
It's BCD.
intercepted arc? It is BCD. So the measure of angle A is half the measure of its intercepted arc. The intercepted arc is BCD. So here we have like this side, this arc here, BCD, is an intercepted arc of angle A. Now, what is the measure of BCD?
100 plus 90.
190. Half of 190
95.
will be the measure of angle A. So the measure of angle A is 95 degrees. Now, let's find the measure of angle B. Now, how did you find its intercepted arc? The first step here, look at angle B, the two sides or the tube has A and C. So the curve from A to C will be its intercepted arc. So for the angle B, we said it is half the measure of intercepted arc. Where's the intercepted arc here? It is A,
It's
B,
ADC.
C. So measure of angle B, its arc is, oh sorry, angle B, its intercepted arc is ADC. Now ADC, what is the measure of it? It's 90
54 plus 90.
plus 60, bravo, which is 154. Half of it will be the measure of angle B, which is 77 degree. So B now is 77 degree.
Like teacher, we said it's half because it's half the intercepted arc, right?
Yeah, this is our theorem.
And this intercepted arc, it's equal to of this angle because it's like, you know, AD and DC, right?
Sorry, what, please? You know, you mean that
And we said
you find the
it's
measure of
equal to-
its intercepted arc.
Yeah.
Ah, yes, you have to add them.
Okay, thank you, teacher.
Now let's find C. To find C now, here, look at angle C. This is C. Its side is B and D. So these points B and D, there's an arc that's connected, or that's connected between B and D, which is D.
BAD.
So the measure of angle C is half the measure of BAD.
Which is 170.
Yeah. Now, how can I find the measure of BAD? You have to add 106 plus 64.
Plus 64.
Half of them will be the measure of angle C. So 170. The measure of angle C is half of 170, which is 85.
85.
So I find now the measure of C, which is 85. Now I need to find the measure of angle D. To find the measure of angle D, we have two ways. What are the two ways?
Finding the measure of the
The
arc,
first
or
way.
adding all the angle measures and subtracting them from 360.
Bravo. This is the first way. And the second one, by using our theorem. Thank you so much. So we can solve it by two ways. The first one, let's solve it using our theorem here. That where's D? This is angle D.
And the arc is ABC.
2 points AC. So this will be now its arc. I don't know what kind. So this is its arc ABC. Now then, so the measure of angle D, it will be half the measure of the arc ABC. Now, the measure of angle D, half ABC. Now, what is ABC? It's 106 plus 100.
106 plus 100.
206. Half of it, 103. So the measure of angle D is 103 degree. This is the first way. The second way, look at the shape of ABCD. As you say, it is a parallelogram. Since it is a parallelogram, so the measurements or the summation of the angles
will be
360. So the shape here now will be a parallelogram. So if this angle 85, if this one 77, if this one 95, so the measure of angle D will be 360 from summation of these angles. So the measure of angle A plus the measure of angle B plus the measure of angle C plus the measure of angle D will be 360. So 77 plus 95 plus 85 plus the measure of angle D is 360. After you solve it, you will find the measure of angle D will be 103 degrees.
Thank you, teacher.
Let's now go to the problem number 2. Here we have this circle here with an angle number 1, and I want now to find the measure of angle number 1. So what is the measure of angle number 1? Let's see now, where is it? It's intercepted arc. Where's the intercepted arc here? It will be this one. Is it right?
Yeah, and make 40 plus x equal 180.
Now, what is the measure of this green arc?
180.
180.
Yeah. It is half the measure of the 180, which is because 180 is a semicircle. So the measure of angle 1 is 90 degrees. This is how we find now the measure of angle 1. Now, since we use this theorem that introduces you to corollaries. What are these corollaries? This is corollary number 2. That says an angle inscribed in a semicircle is a right angle. So this is our second corollary. That's an angle inscribed in a semicircle is a right angle, as we did here. Here we have a semicircle. In the semicircle, there's an angle. The angle that's inscribed in a semicircle will be right. Here's the semicircle, the blue one. Its endpoints will be this one and this one. Now the angle that is inscribed by this two endpoints from the intercepted arc make an angle which will be 90 degrees. So for any semicircle, its inscribed angle is a right angle. So this is our corollary number 2. Now, let's revise what is the difference between theorem, corollary, and postulate. Theorem is a statement that can be proven true by undefined terms and definitions. You have a terms, you have a definition that's undefined, but you can prove it, or you can prove it true and write the statements. These statements that can be written, we called it a theorem. So what is the corollary? Corollary is a statement that's easily proved using a theorem, like it's a result from the theorem. And the postulate, it is a statement that is accepted as true without proof. So the difference between theorem and postulate, that the theorem need to prove, the postulate you didn't need to prove it. It's assumed as a true. And a corollary, it's like a result. It's like a statement that's easily proved by a theorem. Now, as you see that this corollary here, we can very easily to prove it. We say, yes, since it's a semicircle, using our theorem, half of the semicircle is the 90, which is a right angle. So here, what did I do? We solve this question, and because of our understanding of this theorem, we can say, or we can introduce now you to this corollary. Let's solve another one now.
Teacher, the question that we solved, this last question, can't we use the theorem that we solved before? That it's equal measurement 1 equal half.
Yes, I use it, yes. Well, I use it, but here, I told you, I use it. But what did I tell now? I say, like here, since I use it, we can conclude that if there's a semicircle, the inscribed angle of the semicircle will be right.
Okay, so 1, it's right triangle.
Yes, it's 90.
Okay, yeah. Oh, yeah. Thank you, teacher.
Now let's go to another question here. In this one, I want now to find the angle 2. When we don't know either one theorem, which is the measure of the angle is half the intercepted arc. So here, if there's 38, so what can I do? I want to find 2. Now, to find the measure of angle 2, where's this? This is measure, this is 2. So this is the sides of 2. So where's its arc? It is this one. This is a measure, this is the intercepted arc of angle 2. And I want now to find this measure, the measure of this blue arc that can help me to find, I mean that's half of this arc will be the measure of angle 2. So the measure.
Okay, so all the arcs equal 180. So we'll make
measure
equal 180.
So the measure of angle 2 will be half the measure of the arc. Let's name it with x. So this is arc x. Half of the x will be the measure of angle 2. Right. To find 2, I need to find the measure of angle x. How did I find it now? Here we have angle 38. This angle 38 here, this angle 38 here, where's its arc? This is, let's come back here now. This is 38. We have this point and this point. So this will be now the arc that is intercepted to the angle 38. Is it right?
Yes.
So since now this angle 38 has this arc, which is x, so I can write that the measure
of the arc is 38.
yeah, so the measure, yeah, so the measure of angle 38 will be half the measure of the arc x. So that's mean the measure of arc x will be 2 times 38, which is 76. So here we have this intercepted arc 38. So the intercepted angle. Intercepted angle is 38. So its inscribed arc will be also 38. So will be 76. Now let's come back. So here the measure of it is 76. Now let's come back. And we come here, we say that the half the measure of the arc x will be the measure of angle 2. So the measure of angle 2 will be what? .38 degrees. Is it clear?
No. Angle 1 and angle 2 means angle 2 must be 38 because they intersect the same arc.
Yes, that's it. Yes, that's it. Since here we have the angle 38 and angle 2 have the same intercepted arc. So if there are two angles have the same intercepted arc, these two angles will be congruent, as we see here. So that's introduced us to our first corollary that says if there are two inscribed angles that intercept the same arc, they are congruent, like how we did before. 38 and angle 2 have the same angle because their arcs are the same. So they will be congruent. So because of that here, as you see here now, angle A and angle B will be the same. Now, let's remind you now what is the meaning of congruence and what is the difference between congruent and similar. Congruence, that's mean the shapes have the same size and the same shape, like hexagon, 20, the size as our volume as an example, 20 meter cubic, 20 meter cubic. This is the meaning of congruent. The same area, 20 meters square, 20 meters square. Similar, they have the same shape. Both of them are triangle, but they are different size. Maybe the first one is 20 and the second one is 10. See, so congruent, same size and shape, but similar, it has same shape with different size. This is the meaning of congruent. Now, let's solve this, got it here. In the diagram at the right, what is the measure of each numbered angle? Here we have to find 1, 2, 3, and 4. Now, here we have angle 1. Where's angle 1? Yeah, it is here. Angle 1, it has two sides. The sides end at this point and this point. So the measure of angle 1 will be half the measure of this arc. of this arc. This is angle A. It's an angle inscribed by an arc, which is the green one here. What is the measure of this arc now?
It is a semicircle, so
it's
it will be,
so
yeah,
here it is a semicircle, so half of the semicircle. So the measure of angle 1 will be 90 degrees. Now, so from here, if this is 80, this will be 100. And if this is 60, what this will be? 120. Why? Because the green half of the green semicircle, its measure is 180. So if this is 80, this will be 100. And the half of the upper half here is also 180. So if this is 60, this side here, or this arc here, it will be 120. After now we find the measure of angle 1, let's find the measure of angle 2. Now let's come back now to angle 2 here. Where's angle 2? Or where's the inscribed angle of angle 2? This is the inscribed arc. This is angle 2. So it has these two sides at 1 and at 3. So this is the inscribed sides, the inscribed arc. So what is the measure of this arc? It's 120 plus 100. So it is half measure of.
it's half.
Here,
Measure
120 plus 100. So which is, so the measure of angle 2 will be 110 degrees. Now, let's find measure of angle 3. Where's angle 3? It is here. Where is its?
It's 120 and 60.
Where's its inscribed angle? Inscribed angle, it's angle 3. Where's the intercepted arc?
It's 120 and 60.
This one. 60 and 120 or 180, or we can say it's a semicircle. So it will be half.
We really have many ways to solve these questions. Because of that, it's easy.
So half the measure of the semicircle. So which is, so the measure of angle 3 will be 90 degrees. Now let's go to the measure of angle 4. In the measure of angle 4 here, half the measure of its intercepted arc. Where's angle 4? This is angle 4. Now where's the intercepted arc?
It will be 60 plus 80.
4, so this will be its intercepted arc. 60 plus 80. So 60 plus 80, which is 140. So the measure of angle 4 will be 70 degrees.
And if we want to check, we can add them all, and they must be equal to 360.
Now, after that, look at A. A is 90, and angle 3 is 90. Angle 2 is 110, and angle 4 is 70 degrees. What did you conclude?
That because we have a semicircle, the measure of 3 will be right triangle, so it will be equal 90, and the same as
Corollary number 1. I want another result or another conclusion.
Teacher, can you repeat what you've said before?
Here, an angle 1 and angle 3, both of them are 90. And angle 2 and angle 7, angle 2 is 110, and angle 4 is 70. What can you conclude?
Can we say that angle 1 and angle 2 are equal to each other, while angle 2 and 4 are not?
That means they are supplementary. Angle 2
Yes.
and
Yeah,
angle
that's up to 180.
Yeah,
70
right.
equal.
1 and 3, if you add them, they are 180. And 2 and
Yeah.
4, if you add them, they are 180. So what did we say? That angle 1 and angle 3 are supplementary. Angle 2 and 4 are also supplementary. So the opposite angles of an quadrilateral inscribed in a circle are supplementary. So if we have here an quadrilateral shape, the opposite angles are supplementary, like 1 and 3, 2 and 4. If the poly of the shape is inscribed by a circle, and so because of that, the two opposite angles will be supplementary. Now, what's the meaning of supplementary? Supplementary, that's mean two angles with measures that have the summation of 180. The opposite of it, we call it complementary. Complementary, that's mean the summation of them is 90.
90.
Complementary, 90. Supplementary, 180. If we have quadrilateral inside a circle, the opposite angles of this shape are supplementary, as we said, as we saw here in the previous method. So we have 3 corollaries that we learn them today. The first one, that the angle inscribed by a semicircle is a right angle. This is the first one. The second one, that's 2 inscribed angles that intercept at the same arc are congruent. And the third one, that the opposite angles of a quadrilateral inscribed in a circle are supplementary. Let's talk some 2 minutes about this theorem here. Now, if there's a tangent line and there's a chord that they are meeting each other. Since they are meeting each other, they make an angle. They told you that the measure of this angle, that is made from a chord and a tangent line, is half the measure of the arc, which is BDC. So this is this angle here. This is the arc, which is BDC. So this angle that is come between the tangent and the chord will be half this intercepted arc, which is BDC. This is just